a little call like, hey, we're going. It's just, you know, that's just you. You're almost exactly based on. Yeah, it's. The celebrities got no interest. We think daytime talk show after 17 years. This says, a decision that is signed to be.
Right. You guys are gonna get a cheat sheet as well as the notes for today. And this will be your last new thing for the class. Tomorrow and Wednesday, we'll do practice tests. And then on Thursday, you have a test on this chapter. And tomorrow, we're returning books. Try to remember, bring your book and have it cleaned up. All right, so one thing I did, the front of this page is for today's lesson. And on the back, I put those rules for factoring in case they weren't on your factoring flow chart. So you would have that, and then of course you can use this on the test on Thursday. All right, so today what we're gonna do is a lesson on trig. Depending who you had for, some of you would have had Mr. Check last year, and some of you would have had me. Did anyone else have anyone else for geometry? So I'm guessing you have done this trig stuff before. If not, we will go over. There's really only one part that's different from stuff we did last year, okay? So last year we talked about sine, cosine, and tangent, and how those are trig functions that we can use to solve for missing side lengths or angles in a triangle. And it has to be a right triangle. And we talked about SOHCAHTOA. The SOH, this is a way to remember what sine is, what cosine is, and what tangent is. The SOH, the S is the sine, O is opposite, H is hypotenuse. Ka, the C is cosine, A is adjacent, H is hypotenuse. And TOA, T is tan, O is opposite, A is adjacent. So those are things that you have done. Now, what they mean by opposite, adjacent, and hypotenuse is you're always going to have an angle. And this symbol right here is called theta. It's a symbol they use a lot in trig to represent an angle. It would be just like if there was an X here. It's just a representation of that angle. So how I do this is I mark the angle that I'm given. Then across from the right angle is your hypotenuse. Across from the angle you're given is opposite. So notice across is opposite. And then the side that's in between your right angle and the angle that you're given is called adjacent. It's the side that touches your angle. That's a leg. It's not the hypotenuse. So across is opposite, across the right angle is hypotenuse. The side that's between your right angle and your angle is adjacent. Okay, now that we all talked about in geometry, this here is showing us some reciprocal identities, and this we did not talk about. Basically, there are three additional trig functions that you have not learned before. One is called cosecant, one is called secant, and one is called cotangent, okay? And sine and cosecant are reciprocals of one another. So if sine were 2/3, cosecant would be 3/2, okay? Cosine and secant are reciprocals of one another, and tangent and cotangent are reciprocals of one another. So one of the things that we're going to do today is it's going to give us a right triangle, and we have to find sine, cosine, tangent. Those are things you've done before. And then cosecant, secant, and cotangent. Once you know sine, cosecant is just going to be the reciprocal of that, okay? Once you know cosine, secant, you're just going to flip that fraction. And once you know tangent, you're going to flip that again. And again, just so you know, across from the right angle is your hypotenuse. Across from the angle that we have is opposite. And the side that is between your right angle and your angle is adjacent. Okay. So if we try, first I'm going to show you this. One of the things that's going to happen today in our right triangles for this type of problem is they'll give you two sides and you have to find the third side. Now, normally they're not all Pythagorean triples, but if you had me last year, you probably remember this chart. And what this chart is used for is there are certain right triangles, okay, that if you know two sides, you can go to this chart and find what the third side is. It doesn't work on all triangles. It only works on certain ones. But the ones that I put on your worksheet and that I'll put on your test and quiz for this week will always be on this chart, okay? So an example, if I gave you that this is 15 and this is 25, and I wanted you to find that, you would go through this chart and try to find one of the three sets of letters where two of them are 15 and 25. And then the one that's missing would be, do you guys get it? It's this one. So 15 and 25 I have. So that tells me my missing side is 20. Okay. If it wasn't on this chart, you'd have to do Pythagorean theorem, a squared plus b squared equals c squared. But I did not give you any like that, and I won't this week. Okay. So if we go to this, notice one of my sides is 12, one is 16, and I need to know that last side. So if I go back here, do you guys see one where it's 12, 16 something? 20. So I'm going to use this one right here, and that tells me that this is 20. Okay. Then what I would do is look for my angle again. This is theta. I'm going to mark that. Okay. What do we call the side opposite the right angle? Across from our angle theta, do you remember what we call that? opposite. And then this side would be adjacent. Okay. Now, once you have that, you would use these. And honestly, what I do is I do sine, and then for cosecant, I just flip it. I do cosine, and then when I do secant, I just flip it, and so on. The one thing you have to be careful of, though, is your fractions have to be reduced. So if I put sine in here, sine is opposite, which is 16, over hypotenuse, which is 20. That's not reduced, okay? 4 goes into each of those. 4 goes into 16 4 times. 4 goes into 25 times. So that is your actual answer. And then what I would do is go right down to cosecant, and I would flip that. Okay. Now if we go to cosine, cosine is adjacent over hypotenuse, which would be 12 over 20. And again, 4 goes into each of those. 4 goes in here 3 times, 4 goes in here 5 times. So that's your answer. And then this, I'm just going to flip it, find the reciprocal would be 5 over 3. And then tangent is going to be opposite over adjacent, which is 16 over 12. And again, 4 goes into each of those. 4 goes in here 4 times, 4 goes in here 3 times. For the cotangent, you're going to flip that. So it's 3 over 4.
Do we always have to like label it? Like with opposite and adjacent, do we have to do that?
I would, I guess, so you know what they are, but it's not part of like your answer, I guess. But you do need to know which ones are which. Okay. All right, so now if we look at this one again, what I would do is go to that Pythagorean triple sheet, and that is on your cheat sheet if you want to just look at that. So it's 2445. Does anyone see what the third side would be? 51. So it's this one right here, 24, 45, 51. So this right here is 51. If you had done a squared plus b squared equals c squared, you would have gotten 51. Okay. Now what I'm going to do is mark theta and mark what sides I have. So do you remember what you call the 45 if it's across from that angle? Opposite. Do you remember what you call the 51 if it's across from your right angle? Hypotenuse. And then this is adjacent. Okay. So what I would do once I get that is I would come down here and I would just put in the opposite side, which is 45, over the hypotenuse, which is 51. Now, if you ever are like struggling, like that one is not a super, like one that you look at and go, oh yeah, 3 goes in there or something. If you're ever in doubt, you can do, was that 45 over 51?
Yeah.
So you can go 45 divided by 51 and then do math, enter, enter, and it'll reduce it for you. So if it's one that's a little bit difficult to do, certainly use that, okay? So that was 15 over 17. So again, I'd come down to cosecant, and that would be 17 over 15. All right. For cosine, it's adjacent over hypotenuse. Adjacent is 24, hypotenuse is 51. 3 goes into each of those. 3 goes in here 8 times. 3 goes in here 17 times. And then down here, you'd flip it. Okay. And then the last one here, tangent, the opposite is 45, the adjacent is 24. 3 goes into each of these. Again, this is 15, this is 8. And down here, you would just flip that and it would be 8 over 15. Okay. So then what we're gonna do, if we go to our next page, this kind of shows you like what the trig functions are truly for. Okay. So when you are doing trig with a right triangle, what you're trying to do is find either a missing side or a missing angle. And that's what we're going to do for the rest of the time here. And how you do that, you mark this angle, okay, the one that you're given. And then you mark the 2 sides you have, because you'll always be trying to find one and you'll know one. So do you guys get across from our angle we're given? What would that be? Opposite. And then across from our right angle is always hypotenuse. So what you would do, I just kind of cut and paste these over here. You're dealing with opposite and hypotenuse. If you want to look at which one of these trig functions uses those 2 sides, and it's sine. When you do these problems, I only use sine, cosine, and tangent. I do not use the cosecant, secant, and cotangent. I only use these 3. And sine is the one that we're gonna do. So I'm gonna go sine of my angle 32. Now it's defined, you guys could skip this step. Sine is opposite over hypotenuse. So then what I'm gonna do is just substitute those 2 sides in here. So the opposite side is x, the hypotenuse is 8. Okay. To do this, the way I show it is I have you put that over 1 and do cross products. So we're gonna multiply here and I'm gonna put the whole, and this is another thing. When you have a trig function times a whole number, it can get hard to type it into your calculator. So a way that you never have to worry about it is if you're multiplying a trig function times the whole number, put the whole number in front of the trig function. So then when you type it in, it'll be fine. Otherwise, you have to worry about parentheses and stuff. And then this equals x. Now is when you have to make sure your calculator is in degree mode. And if you forgot how to do that, remember you go to this mode key and you have to make sure it's in degree. And if it's not, you would just move your arrows, go to degree, hit enter, and then to get out of here, you can go clear, right? Now, what we're gonna type in is just 8 sine of 32. So we'd go 8 sine 32, and we get 4.24. We're gonna round to 2 decimal places. 4.24?
Yeah.
Okay. And then you can kind of use your common sense, like the hypotenuse is always your biggest side, and that's 8. And so it does make sense for this to be like 4. If this number was bigger than 8, you did something wrong because your hypotenuse has to be the biggest. And a lot of times if you do something wrong, this is a super small decimal, less than 1, and that wouldn't happen. Okay. All right, so let's look at this one. And we are going to do, we have this angle. What would I call the x? Opposite. What is this side? Adjacent. It's in between our angle and the right angle. What trig function over there deals with opposite and adjacent? Tangent. So tangent of my 30-degree angle, and you guys could skip this step. Tangent is opposite over adjacent. So I'm gonna write tangent 30 equals opposite is X, adjacent is 18. Okay. Then I'm gonna put this over 1. We're gonna do cross products. I have a trig function times a whole number. So I put my whole number in front of my trig function. And that's gonna equal 1 times X, which is X. And if you do 18 tangent 30 or 18 times tangent 30, did you get 10.39? Again, use your common sense. If this side is 18, you just wouldn't want this side to be like, 500. Probably not gonna be something, or you wouldn't want it to be like 0.01. All right, so let's look down here. Here is my angle again, so I'm gonna mark that. Across from the right angle, we call that the hypotenuse. What do you think we call this one? Adjacent. It's in between our angle and the right angle. Okay, so we have adjacent and hypotenuse, which is cosine. So I'm going to go cosine of 70. Cosine is adjacent over hypotenuse. And I go cosine of 70 equals adjacent is X, hypotenuse is 15. Put this over 1, okay? And when I multiply here, I'm going to put the whole number in front of the trig function, and that equals X. And then I'm going to go 15 cosine of 70, and that equals 5.13. Now, if I go down to this one, I'm going to mark this. And this side is going to be opposite. Do you guys get that this side is adjacent? And opposite over adjacent is going to be tangent. So I'm going to go tangent of 63 equals opposite over adjacent. Okay, so when I substitute in what I know, the opposite side is X, the adjacent is 2. I put this over 1 and I do cross products. So here I'd get 2 tangent 63 equals X. And then you would type that in, 2 tangent 63, and that is 3.93. Now, the way that, I just have to explain one thing before we move on. The way that all 4 of these examples worked out is we had X on the top of all of these, okay? But that is not always the case. So what could happen with this chapter is you could get something like this. Tangent of 55 equals 2 over X. Okay, you could get something like that. And so I need to show you how to do this. You would still use cross products. You would go tangent 55X equals 1 times 2 is 2, and then just solve that. So you would divide by tangent 55. Okay. And then you would just type this into your calculator. 2 divided by tangent 55. And that would be 1.40. I'll just show you one more like that. So you could get something like cosine of 20 equals 5/x. Just put this over 1, do cross products. You'd get cosine 20x equals 5. Divide by cosine 20. And x would equal, if you do 5 divided by cosine 20, you get 5.32. So that's how you do it if the x isn't on the top. Okay, now let's look at this. So if you guys remember back to first learning how to solve algebra equations, if we give you something like 5x equals 30, and this was multiplied, we did the opposite, which is also called the inverse, and we divided by 5. Okay, so what happens is the inverse of multiplication is division. Just like if I gave you something like this, and it was adding, to solve it, we subtracted, because subtraction is the inverse of addition. Okay, well, trig functions also have what's called an inverse. And what happens is the inverse of cosine looks like this, cosine -1. That's the inverse of cosine. The inverse of tangent would be tangent -1. But what you have to know is, when do I use tangent and when do I use inverse tangent? You use the inverse whenever you're looking for the angle. So if you look here, what I don't know is the angle. It's saying cosine of what angle would be 8/15. What you would have to do there is this. When you're looking for the angle, you are going to type in second cosine, which is going to look like this. Okay, and then a parenthesis is going to come up, and you just type in 8 divided by 15. Okay, so you're going to go second cosine 8 divided by 15, and that is 57.77 degrees. Again, with this, you have to use common sense. With an angle, you should get a number that's bigger than 1 and less than 90. If you did this wrong and you just typed in cosine 8 divided by 15, you would get 0.99 or 1.0 for that angle. If something is 1 or below that, that should tell you that's not a common angle because it's so small. Okay, so you want to think of something like 1 degree is too small, something like maybe even you could think 5 to 90. Okay, so let's try this next one. This one's tangent. So we're going to go second tan. A parenthesis is going to come up, and you're just going to put 2 there. You can put a parenthesis after it, but you really don't have to. And I got 63.43 degrees. So that is a common angle. It's between 5 and 90. It's not a small decimal. That's good. And then this one is sine. We're looking for the angles. So we go second sine. Parenthesis comes up. We type in 0.76. And that is 49.46 degrees. Okay. All right. So now, if I look at the last type of problem that we have, we did some problems back here. where I knew the angle and one of the sides, and we did cross products, okay? In this problem, what we're doing, notice we know two sides, we're looking for the angle, okay? So I'm gonna mark my angle, and then I'm gonna look at the 15 and 8 to see what sides are they. So again, the 15 is across from my angle that I'm looking for, so that's opposite. And what would this be? That would be adjacent. What trig function is opposite over adjacent? Tangent. So I do tangent of my angle X equals opposite over adjacent. And you guys can skip this step. So you'd go tangent of X equals 15 over 8. Now, so that you understand the difference, back here, when we were looking for one of the sides, my X was over here and I did cross products. Notice I know my angle for these. For this type of problem, what I'm looking for is my angle. And whenever you're looking for the angle, that's when you have to go second tan or second cosine. And what you do here is this. You type in second tan, a parenthesis is going to come up, and you do 15 divided by 8. So basically what you're doing here is you're taking inverse tan of both sides. Okay, these cancel. Inverse tan and tan cancel, so you're left with X. And then over here to do inverse tan, I just type in second tan 15 divided by 8. Which is 61.93 degrees. Okay. Now, if I look at this one, I mark my angle. Across from my angle is opposite. Across from the right angle is hypotenuse. The trig function that's opposite over hypotenuse is sine. So sine of my angle X, again, sine is opposite over hypotenuse. So I'd go sine of X equals, opposite is 7, hypotenuse is 13. When you are looking for your angle, that is when you do second sine. A parenthesis will come up and you'll do 7 divided by 13. So second sine, 7 divided by 13 is your angle would be 32.58 degrees. Okay. Then when I look at C, here's my angle. This side is adjacent. This side is hypotenuse. The trig function that is adjacent over hypotenuse is cosine. So I am going to do cosine of X is adjacent over hypotenuse. Cosine of X is the adjacent side is 15, hypotenuse is 17. And I'm looking for an angle, so I do second cosine, 15 divided by 17. So I do second cosine, 15 divided by 17, which is 28.07 degrees. Also makes sense for an angle. Then we'll do one more and then we'll be done. So this one, here's my angle. The 15 is across, that's opposite. The 2 is in between the right angle and the angle, so that's adjacent. Okay. The trig function for opposite over adjacent is tangent. So I'm going to go tangent of x equals opposite over adjacent. When I substitute in, opposite is 15, adjacent is 2. And then these are the ones that I use second tan because I'm looking for an angle. So I'd go second tan, parenthesis will come up, and I do 15 divided by 2. And second tan 15 divided by 2, I got 82.41 degrees. Was it hard? You guys remember kind of doing this last year? So I have a worksheet here for you. I have to make the key. So I will work on that as you guys are. And then tomorrow and Wednesday, we'll have practice tests, Thursday tests, and don't forget to bring your book tomorrow.
We should return this.
Yeah, I returned it today.
Yeah.
So like, that is be like equals x or x equals, so you just put on the order, equals x or x equals for entry.
Oh, yeah.
Yeah, thank you.
Today's draft.
How do you change your calculator to their, because my calculator got none of the answers.
So if you go online, you go and over to the degree and hit enter and then second quit, and you can tell if it's in the right one. If you do sine 90, it should be on.
Okay. If you ever want to check if your calculator is in the right mode, if you do sine 90, it should be 1. So that's a quick way to tell if you're in the right mode on your calculator or not.